What you and I are going to derive next is so fundamentally important in mathematics. I want a different way of rewriting e to the ix power. I is just the imaginary unit, the square root of -1. Now here's my power series representation for my natural exponential function if it's centered about x equals 0. But e to the 3x is nothing more than all this where every x can be replaced with a 3x. In other words, the input doesn't have to be that clean. Okay, so this input is not that clean. But when I take this relationship and on both sides replace every single x I see with an I times x, check out what I get. Now notice how every other term involves an I, and the other terms do not. So if you don't mind, can I very quickly concentrate on the terms that do not involve I? By the way, that's a little sloppy. That's not a 21, that's a 2 factorial. So take a peek at the first term, the third term, the fifth term, and here's the seventh term. Now let me come back and pick up all the other terms. Like the second term, is that just an x? The fourth term is a -1/3 factorial, x cubed. Then the sixth term is a +1/5 factorial, x to the fifth. Now I gotta confess, with the even number of terms, second to fourth to sixth, it looks to me like I missed a common factor of I, so I'll pull it out. However, you check out how. When it comes to what's inside the first set of parentheses, looking upstairs, is that nothing more than just a cosine of x in terms of power series? What you see over here is just a sine of x. Missing the factor of I up front, missing the addition operation in between. This is such a big deal, I've given a name. I call this Euler's identity. You know something really cool about it? Is the following. So allow me to take this relationship and on both sides replace the x with a +1. If I do, don't I get this? And if you allow me to add 1 to both sides. Sorry, can you take it back? I'm going to do something more interesting. I misspoke. If I replace x not with a 1 or anything like that, or a 0, if I replace x with, my goodness, a pi, then I'm going to get the cosine of pi, which is -1 on the right-hand side. And if you allow me to take this just one step further and add 1 to both sides, now that is stunningly gorgeous. That's a nifty little relationship that relates probably the 5 most important numbers in mathematics. The additive identity, the multiplicative identity, Euler's constant, the ratio of the circumference of any circle to its diameter, and of course the imaginary unit. Very impressive.